The Joulescope is a device that lets you measure down to 1 nanoamp resolution and 30 nanoamps accuracy. I took it and I used it to measure on our Elixir board, and we triggered a bunch of different modes from Golioth using the cellular network. This video shows that off. I'm here at the Joulescope booth at Embedded World 2024 North America, and I'm from Golioth, and I'm showing off some hardware that's actually using a Joulescope to measure low power modes on Golioth hardware as it's talking to the cloud over cellular using our Zephyr SDK. Let's take a look at what we're actually building with here. In the demo we have 3 elements. The first is just a off-the-shelf power supply. This is a just outputting 3.8 volts from a USB-C cable, so nothing really special here. But the special stuff is happening on these 2 items. The first is the power is coming in through the Joulescope, and then it's flowing out through the battery connector of this board I'll talk about in a second. It's coming in through the red wire, back through the black wire, in through the current input on the Joulescope, and then back, you can't quite see the cable, but it's going from the output of the current return out to the common ground here, and then back to the power supply. So that stuff all together makes that loop happen. And then finally, the power is actually powering our open source Elixir board. And so this is a NRF9160. On the bottom side, there's an NRF9160, ESP32, a couple of different sensors. And then we have a 5-volt relay board plugged into the click headers. And that's allowing us to showcase when the 5 volts is on or off. We can also show when the 3.3 volts is on or off when we're using the Joulescope. So let's take a look at some of the capabilities that are happening here. So here on the screen, we're seeing the Joulescope live in action, and it's actually measuring current pulses as the device talks to the cellular towers over LTE-M, and we are enabling different modes. Currently, we have it checking in every 15 seconds, and so these are actually 15 seconds apart, sending sensor data back from the Elixir up to the cloud, through the cellular network up to the Golioth cloud. And EDRX is actually making sure that it doesn't actually check in when it's in the sleepiest mode. So we can measure all the way down to its sleep power, and then seeing that it's not checking into the tower. So let's actually take a look at when we turn on these different modes, what actually happens. First thing we'll do is we'll turn off EDRX, and this will happen every time it checks. It'll check in another 15 seconds here, and it'll take, oh, actually I have to hit save. You'll see that it's out of sync until it checks in. So we'll see a synchronization happening here. So this is actually it's both reporting, sending logs, and getting its new setting, and that's sending it back up to the cloud. What we'll start to see now is, because it is synchronized, I click here, it's now synchronized, and these pulses are actually the device checking back in to the tower on a regular interval, checking to see if there's any kind of message for it. You'll see that it's much more responsive now when I change the loop delay. So the loop delay perhaps going from 15 to 60 seconds. So now it immediately got that. There was a setting update there, and it should go and change the loop delay to be longer now instead of shorter. We can also do other things though. We can see that there's logs that are happening, and so we can see the live logging that's happening here. The new set that has been accepting these new settings here as well. I can also do things like changing the power rails and checking out how that impacts the power. So I'm going to go and rerun this RPC right here, which is turning on the 3.3 volt power. I'm going to hit rerun. You can see that it goes and triggers and it takes that new reading. And now what we see is that this is actually turning on the power to the ESP32 and a bunch of other sensors that are downstream from the board, and it's a much higher power content. We see that this is now instantaneous, closer to about 0.3 watts or 300 milliwatts. And that's because we've basically turned on the less efficient parts of the board, including LEDs and different sensors that aren't super power optimized. Once again, we can go and enable this to turn off. We can turn this back off, and we should see it instantaneously turn back down because I reran the 3.3 volt power here. I can also do the same thing for the 5 volt. I could say 5 volt power. And now if we look at the board, we can see that the LED for this, has been turned on, and we're able to, we can then actually enable that relay. So we can dynamically change the power of a device. We can see how it's reacting over here using the logs. We can see that our logs are going to be updated with some of the logging messages that we have there. If we want to, we can go and turn off that logging, again, to save power. We can turn on different peripherals. Or if we really want to, we can actually go and do a remote reboot. This is another remote procedure call that we have. We can go and send a reboot command, and we should see after that command happens, there's a 5-second delay, and then we should see that it's actually now, this is actually the reboot sequence as the thing is powering on. So all of these things are enabled through the Golioth cloud. All these different capabilities are here. It's a small fraction of all the things we do, including OTA firmware, data routing, and different capabilities that are enabled by the Golioth SDK, built on top of ecosystems like the Golioth, or like the Zephyr SDK, which is a real-time operating system. All of these things make it possible for you to build low-power products that are using cellular, Wi-Fi, Bluetooth, Thread, your choice really, but then using something like the Joulescope, you can go and make sure that your device is performing as expected and you have an efficient, effective device out in the field. If you want more information on the Joulescope, check out joulescope.com. And of course, Golioth, you can check out our blog at blog.golioth.io and our range of different examples and support over at forum.golioth.io. Thanks for watching. We'll see you in the next one.